Hi everybody, welcome back. Today we are going to look at section 9A3. Last time we did 9A1 and A2 together, and for this lesson we're going to focus on 9A3, which is solving our trigonometric equations using algebra. So hopefully you looked at the unit circle review game a little bit, because our unit circle is really going to come into play here in these questions. So you might want to have your unit circle handy if you don't have it down, but something you definitely want to going to refer to as we do these problems. So we looked at solving these trigonometric equations graphically before, but now we're going to look at solving them algebraically, knowing what you already know about the unit circle. Let me just give you some examples. The easiest way I can do that is to look through at some examples here. So the first one, as you see, is 2 sine x minus 1 is equal to 0. Well, just like any equation, we want to isolate x by itself. So what I'm going to do is I'm going to add 1 to the other side. So I'm going to say 2 sine x equals 1 by moving the negative 1 over to the other side, right? And next step I'm going to do is divide both sides by 2. So now I have sine x is equal to 1/2. And now my question is going to be, where is sine of x equal to 1/2? So this is where the unit circle comes in. And one thing to keep in mind for this particular problem, we're going to look at only the values between 0 and pi, which actually, that's going to be all of our answers between 0 and pi. There's going to be 2 radians that have a sine value of 1/2 that's between 0 and pi. And where are those sine values? Well, when x is equal to pi over 6 and when x is equal to 5 pi over 6, right? Those are the 2 spots in the unit circle that have a sine value of 1/2. And that'd be our answer. And the answers are in your book as well too, but I just want to kind of show them on the unit circle. Here we go, where we have pi over 6 and 5 pi over 6, and both of these have a sine value of 1/2, so those are my answers. And both of those are, of course, in the range from 0 all the way over to pi, so as a result, those are both of our answers. Okay, let's try another one. Here's 3 problems, and they're kind of related, so we're going to do them all together. So the first one is I've got sine of x equals negative 1/2. Well, for this one, it doesn't look like there's much to do as far as algebraically solving it. We already have sine of x isolated. So think about, where does sine of x equal negative 1/2? Well, if I draw my unit circle out, we know that negative 1/2 is going to occur here at 7 pi over 6 and also at 11 pi over 6, right? In the interval from, now we're looking at 0 to 3 pi. So what does that mean? 0 to 3 pi. So I'm going to, if I travel around the circle, I'm going to go 0, that's pi, and that's 2 pi, and then 3 pi is all the way to there, right? So 0 to 3 pi, how many times did I cross these 2 radians right there from 0 to 3 pi? My answer is just going to be x is equal to 7 pi over 6 and 11 pi over 6, right? So that's my answer for when sine of x is equal to negative 1/2, right? So those 2 answers. Let's look at this next one though. This one's a little bit more interesting. I've got sine of 2x equals negative 1/2. Well, that 2x, I can't just divide by 2 here, because that would be, it's sine of the quantity 2x. So I need to know what that 2x is going to represent. Well, that 2x really is my theta. Isn't that my angle? Because sine of theta is negative 1/2, and I'm looking for my theta here. Well, theta is equal to 2x. So I'm really looking for a value of theta, right, that is equivalent to 2x. Normally, as we said, we have 0 to 3 pi. Well, instead of looking at x between 0 and 3 pi, what I'm looking for, whoops, not x, that should be a pi, 0 and 3 pi. Instead of having just x, I have a 2x. So what I'm going to have to do is I'm going to have to change this range, because I multiplied the x times 2, so that means this is going to now be 6 pi, and well, 0 times 2 is still 2. So now I'm looking at the range from 0 to 6 pi. And what values of sine have what radians have a sine value of negative 1/2 from 0 to 6 pi? So that's what I'm going to be looking at. So if I go back over to that unit circle I have here on the left, and think about it, how many times, if I travel around 0 to 6 pi, what answers am I going to get? Well, if I go 0 to 2 pi, I know I'm going to have my 2x is going to be equal to 7 pi over 6 and 11 pi over 6. But then if I keep going from 2 pi and I go around again to 4 pi, I'm going to get 2 more radians, right? Isn't that going to be, what is that, 19 pi over 6? And also 23 pi over 6. And then if I go from 4 pi all the way around again to 6 pi, I'm going to cross it 2 more times, and that's actually going to be 31 pi over 6 and 35 pi over 6. So those are all my different values by going around the circle from 0 all the way to 6 pi. That's what 2x equals. Well, if 2x equals that, what is x going to equal? I just have to divide everything by 2. So my answers are actually going to be 7 pi over 12, 11 pi over 12, 19 pi over 12, 23 pi over 12, 31 pi over 12, and 35 pi over 12. And that's going to be my answer here. So remember what I had to do. If I had a number that was not just single x, it was a 2x, I rewrote the domain of x. Instead of being 0 to 3 pi, I made it 0 to 6 pi because everything got multiplied by 2. And then I found all the values, all my radians that had a value of negative, sine of that radian was negative 1/2, and it ended up being from 0 to 2 pi, and then from 2 pi to 4 pi, and then from 4 pi to 6 pi. It was all of those, and then I had to divide each one of them by 2 in order to get my final answers. So that one's a little bit trickier. Let's try one more. How about sine of x minus pi over 6 equals negative 1/2. So let's see what happens here. So for this one, instead of having 0 to 3 pi like we did in the original problem, it's now going to be minus pi over 6. So what happens? I'm going to have to put a minus pi over 6 on both of these. Minus pi over 6, minus pi over 6, minus pi over 6. So to simplify that, what's 0 minus pi over 6? That's negative, let me draw a little line here. That's negative pi over 6 and x minus pi over 6. And 3 pi minus pi over 6, what's 18 pi over 6? So it's going to be 17 pi over 6. So that's what I'm going to be looking at here. So what are my answers going to be as I'm going around the circle? Well, if I start at negative pi over 6 and I go all the way to 17 pi over 6, that's going to be, I'm going to have 3 answers here, right? So my x minus pi over 6 is going to equal, and again, if I start at my unit circle, I'm going to go over here and, let's just draw my unit circle again. How about if I do that? So if I have my basic unit circle, and I have this is going to be 11 pi over 6, right? Because I know it's the negative 1/2. And this is my, 7 pi over 6, right? So now I'm going to start at negative pi over 6. So that's actually here, negative pi over 6, right? So my x minus pi over 6 could be equal to, well, negative pi over 6 is one of my answers, right? If I go around 7 pi over 6, there's one, 7 pi over 6. And then also 11 pi over 6. And then if I keep going to 17 pi over 6, I'm going to stop right around here somewhere, so I'm not going to hit anymore. So I'm not going to hit that radian again. So those are my 3 answers. But I have to deal with this minus pi over 6. So can I add pi over 6? Just like over here where I divided everything by 2, here I'm going to add pi over 6 to each answer. So what are my answers going to be? Well, if I add pi over 6 to negative pi over 6, I get 0. I add pi over 6 to 7 pi over 6, I get 8 pi over 6. And if I add pi over 6 to 11 pi over 6, I get 12 pi over 6. And that is reduced. I'm going to get, what, 0, and I'm going to get 4 pi over 3, and I'm going to get 2 pi. And those are my answers for those problems there. There's a few more that I want to do algebraically as well. By the way, here's the solutions to what we just did. You can kind of see how they're worked out in the book as well. There's a few more problems I'm going to do, but I want to save those for a part 2 video on this. So we're going to do part 2 of section 9A3 coming up shortly. We'll see you then. Thanks. Bye.